Chapter 3 is all about matter, and so we're first going to look at what matter actually is. So matter is anything that has mass and volume. This basically boils down to anything you can see and touch. However, some matter is also invisible, and those would be gases. And so it's very important to note that energy is not matter. So energy is anything like light, heat, sound. All of that is not matter. Matter would be more along the lines of like the desk, your iPad, the air you're breathing, the hamburger you ate. All of those things are examples of matter. So matter is anything that has mass and volume, and so we need to talk about what mass is. Because in our everyday language, mass and weight get used interchangeably. And so we need to talk about what those two are. So mass is the amount of matter in a substance or an object. We measure this with a balance. And the SI unit for mass is kilograms. Weight is the measure of a force of gravity that pulls on an object. This is measured with a scale, and the SI unit is what we call a Newton. It's abbreviated with a capital N. However, in English or in the United States, we use that English system, so the unit would be what we're most familiar with is the pound. And so on Earth, gravity causes the mass of 1 kilogram to have a weight of 9.8 newtons or 2.2 pounds. And so it's important to notice that Earth's gravity has a value, and that would be 9.8. And so we will use that when we do some problem solving. So at Earth's gravity, so that tells us right there that gravity is 9.8. What is the weight? So we don't know the weight in newtons of an object whose mass is 10 kilograms. So with those pieces of information, we can use this formula, weight equals mass times gravity, and plug in what we know. We don't know our weight. Our mass is 10 times gravity, which is 9.8, and so our weight would equal 98 newtons. So to try it again, I really do like to list the pieces of information from the problem in the left-hand side, and then just plug them into the equation. And so let's try this with our second problem. If you have a mass of 50 kilograms on Earth, what is your weight in newtons? So we know our mass is 50 kilograms. It indicates that we're on Earth, so we should know our gravity is 9.8, and it wants us to calculate our weight. So using our formula, weight equals mass times gravity, we can simply plug in our 50 for our mass and our 9.8 for gravity, throw it in your calculator, and you'll find that weight is 490 newtons. So make sure you have a calculator accessible for when you're doing these problems. So still on the topic of mass and weight, an object with more mass is going to be pulled by gravity with a greater force. So that means its weight will also be higher. Mass and weight are closely related. The big thing that changes here is that weight can change if the force of gravity can change. And so if you were to go to the moon's gravity is lower than Earth's, and so therefore your weight would decrease. So if gravity goes down, then your weight goes down, but your mass stays the same because the amount of matter you have didn't change. Another unit that we use to measure matter is volume, and this is the amount of space that matter takes up. The way you measure volume will depend on the state of matter that the object is in. So remember, our states of matter are solids, liquids, and gases. So for liquids, in our everyday lives, we use measuring cups and spoons. In science, we use something called a graduated cylinder, which is pictured over here. And our units would then be either liters or milliliters. Our gases, the volume will depend on their container. The gases will expand to fill whatever space is available, so you would have to figure out the volume of their container. Lastly, solids get calculated from their dimensions, assuming that it would be a regular shape. So this would be like for a rectangle or a three-dimensional rectangle or square, we take our length times width times height. If we have an irregular shape, that would be like a rock, or in this case up here, we have this dinosaur figurine. We'd have to use the water displacement method. And so the water displacement method is described on the right-hand side here. You begin by adding water to a measuring container, such as a graduated cylinder, and you would note how much water. Remember, you go to the bottom of the meniscus, and we would be starting with 4.8, let's call it milliliters. And then you place your irregular shaped object into the graduated cylinder. You see the little dinosaur guy went down. When he goes down, the amount of water goes up, and you would now have 5.6 milliliters. And then to figure out the volume of the dinosaur, you would simply subtract 5.6 from 4.8. What do we get there? 4.8 milliliters. So the volume of that dinosaur is 0.8 milliliters. The units here are going to be cubic meters is our SI unit, or meters cubed here. Oftentimes we'll use cubic centimeters for smaller volumes of measure, and it is important to know that 1 milliliter equals 1 cubic centimeter. So we could say that our dinosaur also has a volume of 0.8 centimeters cubed. Either one, the centimeters cubed would probably be more accurate since we're talking about the dinosaur being a solid. So when we talk about matter, we look at its physical properties. And physical properties are things about objects that can be measured or observed without changing the identity of that substance. So for example, the state of matter is a physical property, the color of something is a property, what it smells like, how hard it is, its freezing or boiling points, the ability to dissolve, or the ability to conduct heat or electricity. So for example, physical properties of oxygen include that it's colorless. Here we have color. We have odorless, and we have that it is a gas, so that would indicate its state of matter. Chlorine, on the other hand, is green, so again we're talking color. It's a gas, state of matter, and it has a strong, sharp odor. So all of these things can be observed about chlorine and oxygen without having to change the identity of that substance. So more examples of physical properties here. Hardness. This goes back to our 8th grade science when we dealt with Mohs hardness scale. And that told us how hard a mineral was. And remember, diamonds are the hardest mineral. And their hardness rating is a 10. Anything lower than a 10, 10 is the highest, and 1 is about the softest, and that would be like talc. Freezing and boiling points, that refers to the temperature in which a substance freezes or boils. The ability to conduct heat or electricity, that's pretty self-explanatory. And then the ability to dissolve a substance, we call that solubility. So like the white sand may look like sugar, but it doesn't dissolve, whereas sugar will dissolve. Density, another physical property. It looks at the amount of mass in a given volume. The formula here is D equals M over V, and this formula is on the brick wall up by the speakers toward the right-hand side. So let's practice doing some of these calculations. Again, make sure you use a calculator. So what is the density of a substance that has a mass of 20 grams and a volume of 10 milliliters? So again, fill out what you're given in the problem. So we have a mass of 20 grams, a volume of 10 milliliters, and we don't know our density. Formula says density equals mass over volume, so we can plug in what we know. Our mass is 20 grams, and our volume is 10 milliliters. So 20 divided by 10 gives us a density of 2. And then notice our units are what we're left with are grams over milliliters. One more practice on density problems. We have an object that has a mass of 180 kilograms, a volume of 90 meters cubed. What is its density? So again, fill out what we're given. We're given the mass is 180 kilograms. Our volume is 90 meters cubed, and we don't know our density. So plug in what we know into our formula. 180 kilograms over 90 meters cubed. Put that in your calculator if you need to. And what you get is your density equals 2 again, but unlike that first problem, we now have different units left over. So our units are kilograms over meters cubed. It is important when doing these problems not just to write the numbers. You need to make sure you carry along the units so you can get the correct unit on your final answer. So when we look at a bowling ball versus a volleyball, the bowling ball feels very heavy. It's solid all the way through, and it's very tight. The particles are very tightly packed. The volleyball will feel lighter because it's full of air. It's going to contain fewer and more widely spaced particles. They both have the same volume, but the bowling ball will have a greater mass, and it is more dense. The density really has to do with this statement right here, how tightly packed the particles are. The more tightly packed the particles in a substance are, generally speaking, the higher its density is. So chemical properties are properties that can only be observed when matter undergoes a change to become a new substance, such as flammability and reactivity. Flammability refers to matter's ability to burn, and reactivity talks about the ability of matter to combine or react chemically with another substance. So back to flammability, example would be wood. It has the ability to burn. It can change into ash, carbon dioxide, water vapor, and other gases. And so when a piece of wood is done burning, it is no longer a piece of wood. It has changed to all of these various things. Reactivity, when we look at iron, iron is highly reactive with oxygen, meaning that it combines easily with oxygen to form this reddish powder that we call rust. Rust is an entirely different substance, and it consists of both oxygen and iron. So these are all ways to measure matter and identify various properties of matter.